let's start. Here we go. Let's do that. You can see my screen?
Oh, but we can, definitely.
It's perfect. And the right screen. So the reason me and Tom are talking so much is because we figured that the two companies, Up9 and Lightrun, have a great story for developers, DevOps, SREs, and we felt like we need to prepare to tell that awesome story. So today, we are going to show you how you develop and debug in Kubernetes. We will do some housekeeping. So first of all, relax. Video, everything is recorded, so we'll share that later on through social. There will be a Q&A question at the end, so feel free to send your questions now or at the end and just jump, and we'll be happy to have a conversation. And we both like feedback, so reach out to us at the end there through Twitter, Slack, whatever it is. Tell us how we did. If you have an idea for another webinar for us or something that we can do better, we always like the feedback.
Indeed.
Agenda for today, it's going to be super focused and clear. It's first, what is the problem? Most of you probably have some of the problems. We're going to cover why is it hard to debug in Kubernetes environment, why the microservice requires new tools, and we're going to do a demo of how Up9 and Lightrun are actually debugging a live problem. We'll do some role playing. I'll be like someone that is a QA / looking at errors in the logs and trying to figure out and calling my on-call to solve that. So let's start. First and foremost, why is it so hard? We all know we had the monolith. It was everything running on our laptop. It was fun. And today, if I'm a developer and I'm going into a Kubernetes cluster, first of all, the picture is a lot of moving parts. So we have lots of microservices. And then because, hey, microservices allow you to decouple the technology from the business, every microservice can use whatever protocol they want, maybe one, maybe 5 protocols. So now you need to know Kafka, you need to know GraphQL, HTTP, gRPC. And also because security and lateral movement is so problematic, so everybody implement MTLS, NTLS outside, and it's a really problematic to debug even your pre-production, not to mention your production environment. Yes, microservice gives us the ability to scale, but now we need to have some tools to allow us to co-op with the madness that we have there. So Tom, tell us a little bit, how do we co-op with that?
Well, it's really important to understand that once upon a time when I was young and Refael was not so young, but younger, and
we needed the money. We needed the money.
We needed the money. And it's really important to kind of remember and set the scene for way back when we had when we first started out doing this whole client server thing. And this client server thing is a decision. It's a kind of a very deliberate decision that we made as in the discipline, the software engineering discipline, to start serving our software to customers from a remote location. It makes a lot of sense for many different reasons, and then specifically the entire concept of the World Wide Web came in and demanded that applications will now be starting to be served as, well, not demanded, but eventually we transformed most of the software as a service, being the default model for serving software today. And when we built software system way back when, we had our own LAMP stacks with the Linux machine and Apache and MySQL and PHP or whatever, and everything sat in the same server, everything was self-contained, and you could basically run your application entirely on a single server. You have a VPS at somewhere, maybe Linode, maybe some other kind of earlier hosting provider. I think by saying Linode, I am exposing my age, because if the earliest one I remember is Linode, that problem means I'm rather young. So yes, I'm rather young. And anyways, coming back to it, when an application is monolithic, when it's built out of a single code base that runs on a single machine, all of the interaction between the application happens internally. So components speak between them via inter-process communication or a shared memory or a file or something like that. And there's no external communication, no networking communication between the components. When you break apart the monolith and you make it into something that is distributed, every component sits in its own box, in its own kind of place in the world, then you have a situation in which, and now that I think about it, probably they're not seeing the screen because you're showing it and I'm talking. So I might need to share my screen, I think, Refael. That's a good idea. So I'm going to do that now.
Sure. No, I think I'm sharing the screen.
Yes, okay, no, I hope so. We'll learn the recording later. Anyway, so when we broke apart the monolith into microservices, a few things happened for the components. First of all, private functions, things that talked inside the code, inside the application itself, were not exposed to the outside world, remained internal code. They're still there, hidden away from sight. But any public interface basically became some sort of internal API that is used between the applications. So one component that needs to talk to another component speaks to it via those internal APIs. In addition, external APIs still need to be accessible. So now there's two layers of APIs that need to be exposed or are actually exposed to the wide world. One of them is that what used to be the public interface and became the internal, now became an internal API for microservice communication, and the external APIs that we need to maintain anyways. So we have two layers of communication, not to mention the original private functions that are buried somewhere in the code, distributed across many different microservices, sometimes spread across clusters, spread across clouds, spread across languages, obviously, and all the complexity. Complexion is something else. That's your skin, the face on the skin on your face. That's complexion. The complexity is abound. If you can move on to the next slide. And I think if you don't mind, Refael, I'll take this slide and kind of walk you through this as well.
Go ahead. I trust you.
Yes. I literally do this for a living, Refael. I think you can trust me. So
really, you get paid to talk about your work. Amazing.
I know. It's insane. The fact that I get to speak and then get money based on the fact that I talk is still miraculous to me. Amazing. Anyways, this diagram in front of us basically shows what we did in order to understand or debug, monitor what is actually happening in this new world that we're in. And because in the monolithic world, everything was, I wouldn't say everything was much simpler, but it was a bit simpler than it is now because we didn't have the overhead of networking and multiple different things talking to one another over the network. When we started breaking them apart into microservices, we needed a way to control the communication or monitor and observe the communication between those components. So Up9, which is the company that Refael works for, built a system that enables you to observe all the communication between the microservices. We'll see Mizu in a moment, which is a core product from Up9 that enables you to look and trace and see telemetry and observe requests between all of those microservices and how they communicate between them. Up9 is very good at this type of distributed telemetry and tracing, and Lightrun comes in on the lower levels, basically on the internal, what used to be the internal components, and enable you to observe the code and see what happens behind the services in interfaces that are not publicly accessible, but are internal to the application itself. And this might sound a bit weird. We call it developer observability, and we will be able to better explain it once we go through the demo in a few minutes, actually. Refael, do you want to move on?
I think if the code in the monolith was just an include away, today your code is just a pod away, or maybe pods. So it's tough to understand which code ran at which pod and was it executed or not, and protocol, etc. So those two tools literally give you the end-to-end lay of the land for developers to basically understand where the problem is quickly and how to debug it regardless of the environment. It's the same for development and production.
Indeed. So I want to kind of explain about why microservices applications behave differently. And that might, again, we talked a little bit about it, but let's get specific. So first of all, when you take a monolith and you break it apart, what you actually do is you create more servers. You had one server, and now you have multiple servers that need to communicate between them and also to the outside world. So first and foremost, moving from one instance to multiple instances creates race conditions. You have resources that used to be singularly accessible, and now they need to be accessed by multiple parties at the same time. So that's a bound thing for race conditions, and you have to account for it both in your code and in the resource you're trying to access. So instead of opening one connection to a database, you might open 5. And that's also something that you need to consider that you didn't have to do before. In addition, networking overhead is a real deal. You have many more requests happening inside the network. Congestion is a problem. Communication is a problem. DNS is now a real pain in the behind. And of course, if you talk about anything that has to communicate between one another, that means there are problems that are bound to happen in the clients and the servers that does the communication, which is outside of the scope of your application, but might happen and might occur. And specifically your developers and even operation people might not have a core understanding about it. Speaking of multiple instances, when you look at a piece of code that is expected to run once in a specific location, and now you're making it run 5 times in 5 different locations, the logic inside your code might have to change because the output of those systems now require different requirements. Demands different requirements. You need to maybe parse it differently, maybe choose which information to emit, which not to emit, and so forth. A lot of considerations would go into that. Speaking of networking and trying to communicate between everything, it's really difficult to understand where something is actually running. Which pods in a normal Kubernetes cluster, when pods go up and down like crazy, it's really difficult to understand where your piece of code is running. And with load balancers in the way, it's difficult to understand which pod received which request. It's a nightmare. Unlike what you might have been used to in a normal server, where you just tail f/var/log and find the relevant file you need, it's almost too complex these days to locate your codes in a normal cluster. You have to figure out which name, which cluster, which namespace, which pod, which container, tail those logs and only specifically, see those logs specifically and filter and combine them with logs from external resources as well to get the full lay of the land. I'm copying Refael, to get the full lay of the land of your application. So basically transactions are complicated. That's what we're trying to say. And speaking of which, performance of those transactions is also complicated to debug because of the networking overhead and the multiple resources that are in play. I talked a lot and very, very fast, Refael. I think now it's your turn.
That's fine. Let me take it a little bit from here. So first and foremost, what you want to have is a tool that will allow you to easily find the problems when they occur. And this is why we created Mizu. Mizu is like a Swiss knife. Basically, it's a point and shoot tool. You just do kubectx to wherever your cluster is, download the small file, 13 megabytes, Mizu tap, and you will see your entire cluster communication. And the beauty of it is that, first of all, it's agnostic to the protocol. It doesn't matter to us which protocol you're using, if it's encrypted or not. Mizu is just opening that up for you and bringing it to you using various amount of technologies like eBPF, attaching to the kubectl APIs, linking itself to Linkerd and Istio to get the MTLS. So it gets that. The second, it allows you to slice and dice your traffic, meaning you can say something as simple as give me all the response codes that are above 400. Or you can even say, I want to see all, we talked about performance, I want to see every request that took longer than 500 megabytes, or that the size was bigger than a megabyte or something like that. I said megabyte on the response, maybe I meant milliseconds. So,
megabytes, milliseconds. Yeah, exactly.
And the beauty of it is a point and shoot tool, meaning like you do Control-C and it automatically removes itself from the cluster, leaving no traces behind. So you can just go use it on your dev, your pre-production, and just see that. The best way is to describe Mizu is that if you merge Wireshark and TCP dump into your pods and bring them all the way to your dev tools in Chrome, that is what you will get. You will get dev tools for Kubernetes that allows you to debug your traffic. And to complete the picture, once you figured out where the problem is, now you want to drill into the code, you have Tom with Lightrun.
It is I. So Lightrun, again, is a developer observability platform, which is a fancy name for saying we allow you to add logs, metrics, and traces to production and staging environments in real time and on demand. And this includes you don't actually have to hotfix, redeploy, or even restart the application. That might sound a bit weird. We're going to show how it actually works in a bit, but you can think about it as a power tool for your on-call people and for your developers who are trying to understand what logic is actually taking place inside their production applications. In fact, if you can move on to the next slide. I just wanted to mention that we support both JVM languages, so Java, Scala, and Kotlin, Node.js, including TypeScript, and Python 2 and Python 3. Although if you're still running Python 2, it's about time to update. The use cases is the main use case for Lightrun is kind of enabled by the sandbox mechanism that we have. Lightrun is a read-only observability tool. We have a sandbox that evaluates every information that we try to insert into the application and make sure it doesn't change state. Lightrun is highly secure. We integrate with the popular IDPs with ISO 27001 compliant, very soon to be SOC 2 compliant. Our footprint is minimal, despite the fact that we do instrumentation in real time. We don't actually do a lot of overhead for the machine, and everything is kept anyway for you to make sure that your application performance is not impacted. We can privacy redact, if you will, most of the information that Lightrun emits, actually all of the information that Lightrun emits, but you can redact only the information that is considered private. For example, credit card numbers, social security numbers, and so forth. And we basically run anywhere your code runs. We're pretty agnostic. All we care about is you add the Lightrun agent to your runtime. So if we work in AWS Lambda, we work in Kubernetes, we work on bare metal servers, we work, again, basically anywhere that your runtime can run, we can work. I don't want to stay much. Yes, exactly. So thank you, Refael, for this, for kind of laying the ground for me. We do a lot of ground laying and kind of lay of the landing today in this webinar. I feel as if we do a lot of groundwork, a lot of like,
we're explorers, we're travelers.
Yes,
through
exactly.
The Kubernetes madness.
Definitely. So I don't want
the next Doctor Strange, just so you know.
I understood the reference. What I'm worried about is whether our participants will understand the reference. If anyone understood the reference, they can raise their hand now. And I expect to see no hands raised in the attendees, because that was a very vague, obsolete, esoteric reference out of nowhere, Refael. Thank you very much for that. Anyways, speaking back to the Lightrun architecture, again, I don't want to spend too much time on it, because if you want, you can just go into our website and read a little bit more about it. But the general idea is that a developer inside their IDE right-clicks somewhere inside the code, adds a bit of information, and basically can see that information live in production. The way it actually works is that we have 3 components to the system: the IDE plugin. We support IntelliJ, VS Code, all JetBrains IDEs that support our languages, and VS Code, and also VS Code for the web, which is soon to be released. And in addition, there's a management server. The management server can either reside on-prem in your locations, we just give you a Helm chart, or can reside in our end on Lightrun side. And the agents themselves, the runtime agents, an NPM package, a pip package, and a native Java agent for the JVM. What basically happens is the communication is as follows: you instrument, or you right-click inside the IDE and ask an action to be instrumented. The management server receives this API call and says, okay, now there is state to instrument. The agent on step 3 receives these instructions by long polling the management server. If you pay close attention, because the agent long polls the management server, that means there's no debug port, and the developer does not automatically or directly connect to the machine ever, which means we don't break things like SOC 2 compliance, which is why we're basically SOC 2 compliant. The intention, after the agent long polls the management server and it receives the states that need to be the state that needs to be instrumented, it instruments it and then can dump the information, the logs, the metrics, the traces to anywhere you'd like, either to your APM or back into the IDE. We'll see that in a moment. Again, if this is a bit unconventional to you, that's perfectly fine. This is a topology that is common in instrumentation agents as a whole. And I believe that it would be, if anybody has specific topology or networking questions, I'm available either on Twitter at Tom Granot or in questions here in the webinar. Sorry, Refael, for the plug. Go ahead. Let's do the demo.
Let's do the demo. Okay, so I'll move you here, Tom. What we have here is a nice application that sells an amazing amount of SOCs. And what we want to do today is I'll act as a QA / somebody that kind of noticed a lot of issues or we got a lot of 500s, and I'm going to try and debug that. The first and foremost thing I want to do is I want to trace them. So I will do that. I'll go to Get Mizu, and I will just download Get Mizu. In my case, it's I have an M1, so I'll just take that, put it in my command line, and voila, now I have Mizu downloaded. Did I mention Mizu is open source? No, so Mizu is open source. The beauty of it is that what I can do is can do just Mizu tap. I can do tap my entire cluster, all the namespaces and everything, or I can just say, hey, let's focus on SockShop. This is the namespace where that application is installed. And what happened now behind the scenes, if I'll show you here, this is the SockShop application. And Mizu just verified on which nodes of the cluster we have those pods. And it launched 3 daemon sets and a nice API server. This is the API server. And those daemon sets are the ones that capturing the data and the traffic and just sending it to us here. So once we do Control-C, the cleanup has been completed and there will be no traces. Great. So I want to start debugging the problem. Let's focus on our HTTP. So what I'll do, I'll just minimize this to HTTP. Great. And I said I want some errors. So I'll take the response code. I'll say, hey, show me everything that is higher than 400. And everything that I'm doing is live, right? Oh, interesting. We get some GraphQL. Interesting. Okay, let's try and run some registers. So I'll try and register with a user that already exists. And oh, I see we get a 500. So let's focus on specifically register path.
If you don't mind me saying, Refael, this is actually a very common occurrence. So if you look at any application, especially in microservice environments, sometimes you get requests that are created based on things you did not expect to happen. So for example, a lot of the time, a service calls a service, calls a service, calls a service, and then you're trying to understand which request failed where, and it's very difficult to understand because of all the interconnected components. So in here, for example, what you expect to get is some sort of informative message, right? Some sort of informative response code, sorry. Instead, you're getting a 500, an internal server, which is completely, not helpful.
This is the great thing. So we talked about the first and foremost is it's hard to understand what is the trace. So what you just saw right now, I just did another register and I can clearly understand this is exactly what we will see if we'll do the dev tool. So if I'm doing that, this 500 is my IP to the front end. And now Mizu allows us to look inside the cluster and understand first that front end called the service called user, and then the pod responded to that. That's why we see those. And not only that, if we want to see how it fits into the entire application, then we can see all the relationships at the moment and understand if something had to do with payments or not. So we get an overall picture of the entire application and the specific trace that we want to do. So the first and foremost, I can go here and I can see everything, the request, the response, everything here is also, I can just filter about that, including the past time, and we'll talk about the rules in a second. The second thing is I can go directly to the pod and see what happened from the pod perspective. And at this point, I understand I have a problem. So what I'm going to do in a normal case, I'm just going to call my on-call on Slack and kind of say, dear on-call, we have a problem. So Tom, do you mind to join me on a Mizu debugging session?
Yes, I can. And just to give a quick reminder, and Refael, I think I will share my screen now.
Go ahead.
Everything that Refael can see, I can see too, because Mizu can work in 2 ways. You can tap into an existing Mizu session that is attached to your cluster, and you can basically view the same things exactly that Refael is viewing, which is very cool, very awesome, and very useful. What I want to do now is I want to basically look at exactly what Refael is doing. Refael, if you can retrigger the register path, that would be great. And I should get all of the traffic that reaches register in just 1 moment. While it does that, I want to, and there you go, you can see these 500s coming in from the register. What I want to do, and we only have a few more minutes, if anybody has questions, then I think we'll stay for like 1 or 2 minutes afterwards just to answer the questions. Refael, is that okay with you?
Yeah, for sure. Just post them on the chat.
Yes, exactly. Just post the questions on the chat and we'll answer them. I just want to show a quick thing. So again, we looked at Mizu and now we're trying to understand whether where is this 500 coming from. If I go to the code that is actually behind this path, I'm now inside, if I look at the tree of this application, there's this API /user/index path that contains a path called register. If I look at this route, you can see that there are a bunch of information is coming in. Again, this /register path is this /register route. What I want to do is use Lightrun, which is conveniently placed on the left-hand side here, to investigate this service. You can see on the left-hand side that I got a bunch of things already up and running with Lightrun agents. Lightrun agent is basically, again, a package that you add to your runtime. If I look at my K9S, I can see there's a bunch of pods running here, doing different things inside this application. For anybody non-familiar, K9S is just a way to observe a Kubernetes cluster in a very nice way. If I go back to my application, you can see that they have 5 Lightrun agents already set up on some of those services, so we can debug them. The interesting service on this end is the front-end service, which also acts as the API gateway. What I want to do is I want to show you how you can place a breakpoint without breaking the service. A breakpoint is a very useful piece, a very useful bit of information, contains a lot of useful bits of information that might help us debug this 500. What I'm going to do is I'm going to look for a 500 inside the code. I can see that in line 234 inside this register route, there is a bunch of information that relates to the error, but the Mizu interface, as well as our logging application, doesn't actually tell us a lot of information. I want to see the full context of this user while the application is still running. So what I'm going to do is I'm going to right-click, add a Lightrun snapshot here, insert a snapshot. I'm going to choose to place the snapshot on the front-end engine, on the front-end service, sorry, and I want to make sure that we get a lot of hits. A hit is basically a breakpoint invocation or execution. Basically, whenever this code path is invoked, a new snapshot will be captured and you will get all the information for that specific user. I'm going to click create. And once I do that, the snapshot is going to be taken. Oh, sorry, I forgot to give it the full file name. I need to give it the exact location because there are many files called index.js in this application. I'm going to apply the changes. It's going to reload and it's going to run. Now we can see that the snapshot has been added. You see this blue check mark next to the application. Refael is now going to reinvoke the register path. It just did. And if I go to the snapshot tab and I look at the information, I can see the full lay of the land, sound familiar, of the application right here. I can see the app function. I can see the response, including which encoding was used, what output is given, all the information about a sync and the relevant limits inside of it, all of the relevant endpoints that are discoverable via that specific property, all the helpers that are available for us to use, the options which contain a bunch of interesting information about the body and the relevant information that is available here. You might note that it's the same information that's available here. That's not by mistake. It's actually the post data, because that's how the express route here works. And again, a bunch of different contextual information that might be interesting for the people debugging this to explore. And I think that this is basically the point where the on-call stops, copies this information over, brings it over to the ticket for the developer to do their magic, and then debugging becomes much, much easier. Of course, because Refael, if you don't mind invoking this register path again, you will see that once Refael basically tries to register again, another snapshot hit will be captured, and you can get even more information that is enabling you to debug it even better. You can see that I have 2 hits here that contain 2 different parts of information collected at 8:27 and 8:29 p.m. Respectively. And this again enables a smart developer to look at the full context of the information without having to reproduce, which can be very, very useful for them. Snapshots can be exported and imported as you will into different locations. You can basically export it, place a link inside a Jira ticket, and then you're done. Very useful, very easy for debugging. We have a bunch of other features that we are not able to cover here. But if you have any questions, again, at Tom Granot or Twitter, or drop us a question here on the chat. Refael, take it away.
One more thing that I want to mention is that it's conventionally, let me just share my screen here and then I'll do the talking. So usually we can always say, hey, let's do a printf to like a log and then throw that log to a log aggregator and then do the search. The beauty of those 2 tools that you just saw, one, we don't need to change the code. We can do everything in real time. The second thing is that we collect only what we need. So think of like the amount of login and register. You are now able to get down into the exact register that you need, even a specific user, because you capture the body, you can filter it in Mizu only on that body. And then you can go back to Lightrun and kind of say, hey, only in those certain conditions, I want to see that. The logs are kept very focused, but you get the entire information to create your Jira ticket for the developers to understand exactly how to reproduce that, how to grab that, and how to validate after they solve the issue to make sure that it doesn't happen again.
Most def. Thank you very much for that clarification, Refael.
So
Go ahead.
let's see if we got any questions. See. Can Mizu support TLS? Yes. So thank you for the question. Mizu utilize eBPF to actually do TLS. You can launch Mizu. Of course, it will require the Linux capabilities for that. But once you give that permissions to Mizu, Mizu can capture all the TLS traffic. Really useful if you're debugging third parties APIs, such as, let's say, GitHub or Stripe or a third party that you're contacting, and usually it will be HTTPS. So Mizu will be able to do that. You can turn it on and off. So like Tom said, Mizu comes built in with redact feature. So authorization keys and etc. won't be there. You can turn it on when you need to debug seeing everything and then turn it off later on. Same for the TLS. Tom, you want to take the next one?
Yeah, so we have a question about Lightrun here. How is Lightrun actually doing the checking in the sandbox? That's a very good question. I assume what you're referring to is what I mentioned about looking at the instrumented instructions. So Lightrun has a sandbox mechanism that checks every line of instrumentation that we have. Basically, we look at the logs that or metrics and snapshots that we add to the application and then validate that it doesn't change state. The way we do it actually changes by runtime, and it's a bit kind of tricky to get into all the specific into it now, but you can think about it as if we inspect the actual intermediary representation or bytecode, or again, however you'd like to refer to it, inside the application before it actually is invoked, and check that there is no writes, there's no request going out, no complicated parsing, and so forth. Which means that you are would be limited by some things you can't do because it will change state, like making a call to a database, but it will also ensure that the application is completely safe because Lightrun is read-only. We don't touch your state unless you want us to, and even if you want us to, you can't because we're read-only. So that is the nature of the tool. Thank you very much for the question. Refael, I think that's about all the time we have, and we're already a bit past you, aren't we?
Yes. Tom, thank you very much for joining me.
Thank you for having me, Refael.
I think maybe we'll convert it to a series of podcasts at one point. We'll see.
I would not mind at all. This is very fun. Always fun to hang out with. Thank you very much.
Amazing. Thank you everyone for joining us, and we'll see you on social. We'll share that later on. Bye-bye.